Have a great break. Okay. We're looking at day 2 and 2.8, and we're looking at example 7. We didn't see one of these, the square root of 7s or square root in there. And what I want to make sure that you know as we go through, those restrictions can be shown in your sign chart. So I've got my zeros, which is 3. But I also got my other consideration, wherever my 0 is, thank you. I got my other consideration that x plus 1 must be greater than 0. Okay, not because it's greater than 0 in our inequality we got to solve, but we can't take a square root of a negative value. So x plus 1 must be greater than 0. So when I'm looking at that, I got to know that x is got to be greater than or equal to negative 1. Okay, but that would mean I have this function undefined when x is less than negative 1. Okay. So when I'm looking at my sign chart, and I'm going to bring that up, I got my undefined area here. I got a 0 at negative 1, okay, because it's 0 there. It's okay for me to have a 0 there. And it's okay for me to have a 0 at 3. And now I'm looking at it, and I'm looking at the function itself, and I'm thinking about a number between negative 1 and 3, which is 0. So I pop 0 in for x here, and so I've got a negative value, and I put a 0 in here, and I'm going to have a positive value. So I got a negative and a positive, and their result is negative. And then I look at a number on the right side of 3, like 4, 5, 6, I don't care what your number is. I pop it into my 2 factors to determine what the sign would be over there. Okay, whether it's 4, whether it's 40, it's going to be the same sign. So it's going to be positive and positive, so I've got a positive result on my sign chart. Okay, now they're asking me when is all that going to be greater than 0? Well, it's greater than 0 from 3 to infinity. So by sign chart, I have negative 1 and from 3 to infinity. So I got to remember, I got to include my negative 1, which is also a 0. Okay. And then I go from 3 to infinity. Okay, does that make sense? I'm just looking for what's positive as my answer by sign chart. Okay, or 0. And if I look at my graph, that makes sense because it totally works here and it totally works here and on. Okay, for my answer. Totally positive or 0 in those spots. Now, I'm not sure if I asked this question. I had a investigation on it with a few students, and they said no. So here it is. How much does Santa's sleigh cost? Nothing. It's on the house. Hey, I never said they were good jokes. Okay? All right. I know you guys are going to be telling that, though. Grandma's going to love that one. All right, so here, when we're looking at this, make sure you talk about your solution, and we're talking about the sign chart, and we can check our solution with calculators to make sure we're right. As we go, we also haven't talked about, hey, what happens if I have an absolute value? But really, what's the absolute value of a negative value? Positive. The absolute value of a positive value is positive. So I'm not really adjusting too crazily here. I'm still going to talk about my undefined. Okay, so I'm talking about my undefined value, got negative 3. So whether it's going to be positive or negative, underneath, it's always positive coming out. But when it's 0, it's definitely 0. So that is a restriction. And I've got a 0 at x equal 2 because that's my top. It's where it's going to be 0. I plop it in and I put in 2 minus 2 and I've got my 0 there. So I'm looking at my sign chart. If I've got my sign chart set up here, I hate that when I do that. I apologize. I thought I had that set. There it goes. And I'm looking at it, and I like to stay out of the way for the folks that are behind my back, so I apologize for tapping on the wrong thing. I stopped my undefined and my 0, and I got my first check in there. something to the left of -3 is -4. So I got -4 minus 2. Well, it's a negative on top. And I got -4 on the bottom. It's negative inside, but it's a negative absolute value, right? So it's a negative divided by a positive. That's why it's a negative result. So I do the same check between -3 and 2. I'm going to grab 0 because I like dealing with that. So 0 goes in of x minus 2, and that's negative on top. 0 goes in, it's positive on the bottom, so that's what I've got going on, and that's going to be negative as well. Now, I'm getting this idea that it's diving, my function's diving at my asymptote, my vertical asymptote. Now, I'm checking on the right side of my 0, okay, and there isn't any tangents or, dual multiplicity, so it's not going to be like a bounce on my graph. I'm thinking it's crossing. And I'm going to try 5. 5 minus 2 is positive. 5 plus 3 is positive. So I got a positive over an absolute value of a positive, which is still positive. And I've got my setup of my function negative, negative, positive. Now, we're wondering when it's going to be negative. So it's negative from negative infinity to -3, and from -3 to 2, and it includes 2 because it's negative or 0. So I'm okay with it being negative or 0 all the way up to including 2. And that's my answer by sign chart, if I can get that a little higher for some of y'all so you can see it better. Now, does it make sense as we go through this one today? And are they a little easier than yesterday as far as being able to determine what the sign of your function is, so you have a general idea of what its behavior is like around the axis, around your asymptotes, and more importantly, the solutions for inequalities, okay, when we're dealing with them. Now, the next two problems we've done before. We are just using the ideas of our sign charts today to help us with working with them, the real life ideas that we have today going on. Designing a box. Well, remember this designing a box. We had this box. We're supposed to cut out x squares that are x by x, squares that are x by x. All right, in order to deal with my box's requirements. And we're looking at Dixie Package Company has contact with another firm to design boxes with a volume of at least 600, okay, of at least 600 inches cubed. Squares are still to be cut from the corners of a 20 by 25 piece of cardboard with flaps folded up to make an open box. Now, if I do that, I'm going to subtract 2x from each of those values in order for x to exist. Okay, so and remember, my resulting box is going to look something like this as I come through. That was a really nice box, where I've got my x high, I've got my 25 minus 2x on the side and 20 minus 2x on that side, and that's going to be x high, and that's where the 2x are subtracted away. So my dimensions here are going to let me say that. I got 25 minus 2x times 20 minus 2x times x. Now, my relationship to solve on this box, okay, that's my general volume. Are you okay with pulling out that volume for the box that we've been working with? Now, they said here in the problem, with another firm, design boxes with volume of at least 600. So this volume has got to be greater than or equal to 600 as we go over this. Okay, greater than or equal to 600, because that's that word at least. 600 is the smallest the box can be, but it's got to be, could be exactly 600. Now, in my graphing calculator, I want to set up the volume function, okay? in Y1, I'm going to put my 600 in Y2 so I have that relationship in my graphing calculator. Now, keep in mind, I have two graphs that are going to cross. So I am going to put them in, and I am going to come out with the spot where they cross. I'll have my X value, and I'll have two of them. I got one here, I got one here. So when I pop those in, my result will be 1.669 is my first one. 1.669, remember I rounded. And my second one here is 6.160. Okay, now I completely put those in my calculator. I pulled these off. I took a snapshot of my calculator screen so you guys could see what that would look like. It was a much better screen than the other graph I had before. Okay, now I've got those two, but now I've got to talk about what that means. Is it going to be greater than? Okay, so it's over the top. It's greater than 600, right? So it's between 1.669 and 6.160 inclusively, which means includes those. That's why it's bracketed. Okay, but what does it mean? Square cutout side lengths are between 1.669 and 6.16 inches for the volume to be at least 600. That's my range. Okay. It could be as small as a cutout as 1.669 inches by 1.669 inches. That's my height of my box, okay? Or as big as 6.16 inches, okay, out of my corners to make this volume work. Is there any clarification on this with my inequality? Are you okay with how I decided my box would have this volume? And are you okay with the relationship we've got to solve that it's got to be at least 600, which means it's greater than 600 or equal to? Okay. Now, in the same flavor, we're looking at revisiting our juice can. Okay. Now, I did the juice can a couple times this morning with some folks to talk to them about it, and I want to be clear about what I'm doing with the juice can. Stewart Cannery will package tomato juice in 2 liters, that's 2,000 centimeters cubed, cylindrical cans. Find the radius and height of the cans if the cans have a surface area that is less than 1,000. Now, what we did before, we talked about volume and surface area. Okay, so I got my volume going on and I've got my surface area going on. Now, in the problem, they want me to have my surface area less than 1,000, okay, for my can. And the question that I really kind of dealt with this morning is people, why did you decide to solve for H? I'm going to be real kind of open about it. I could have solved for R or H when I was working with my volume function, okay? It wouldn't have mattered. I chose to solve for H because it was easier, okay? Because otherwise, if I solve for R, I'd have to take the square root of stuff. And then I'd have to plug it into an equation and work with that square root. It would just easier for me to solve for H and then find R after the fact. Or, you know, solve for H and plug that in to find my H after the fact, I should say. Okay, because if I put this in and I solve for my H, I now have H in terms of R. Okay, so I can pop this into my function right there. And I just have one place to put it in. I don't have to put it in multiple places because I have R squared and R, so I had to put it in twice. This way I only have to deal with H, and now I've got it in R, or you know, I can use it as X. I solve for my radius, and then later I use my radius to find my height using the same function for H. That's why I chose to solve for H. It was the quickest substitution. Now, with all the restrictions that I've got going on, I've got this happening. And just like we did, was it 2 days ago, I think it was, I have my pi's knock out. This R squared and this r becomes just r to the first. And I got 2 times 2,000, so that's where that 4,000 comes from, over r. And now here's the thing. In my calculator, I put in this is y1. That's in y1. This is in y2. And I get my calculator picture here. This first side, maybe I should color code them, but this is coming down here. And this is my y1. My y2 is coming straight across here. Okay, so I have my functions doing what it is. My setup is my function. When's it's less than 1,000. So it's less than 1,000 in range between 4.619 and 9.655. And how I found those is where they crossed, and I made my decision that it was less than 1,000, so that's how I found the range. I could have looked at it as when is it a greater 1,000, from, way down to way up, but that wouldn't make sense. See you guys, good luck. Okay, now with that information, I've got to find the heights, and I'm just finding the heights based on my values that I got for 9.655 and 4.619. One of the things that was fun today, right after I did my calculator check, I had in my function, I had my function in there. I had y1 equal my 2 pi x squared plus 4,000 x, and I had y2 equal 1,000 in my calculator. Well, I was dealing with the fact that when I ran this, my calculator had x equal 4.1619. Are you guys okay that the calculator returned that value? I went back to the regular screen, and I plugged in my function 2,000 divided by pi x squared, like that. I put that in the main screen because now x, right now in my calculator, has 4.619 in its place. So after I put this function in my calculator in the main screen, I hit enter, and I was able to come up with my answer for my height. And then I went back in, did my trace, came up with my other 9.655, went back to my main screen, hit second, recall, and put this back in because x is now 9.655, and I ran it and came up with my other h. So I didn't do much with finding these values. I used my calculator to pull those off. I didn't do a lot of manipulation by hand or anything. I allowed it to happen in my calculator because after I did my trace, my x value was defined. Yeah? Well, when I do that, what we're finding is the height. And when I have a radius that's really big, my height's small. Okay, so I had a radius that's really big, and my height went small. And I think I did something funky with that. These are my heights. Okay, when I get this going, but you got to keep in mind, my 9.655 returned my 6.83 height. And my 4.619 returned my 29.835 height. Okay, because of what's going on. The smaller that radius was, the larger the height is, because it's holding that volume. Does that help? Okay, any other clarifications? Remember, smaller the radius, the bigger the height. The bigger the radius, the smaller the height. Holding the volume the same. We're good? It's my last thing, man. So we have that for today's assignment. Want to make sure that you're using your time. I updated assignments this morning, so you guys got some more stuff from me, so I'm behind. Thanks. Really appreciate you being on top of things. Make sure you're getting things ready. I'm here tonight after school. I won't be here tomorrow because I have a meeting in the morning. Tomorrow night after school and Thursday morning and Thursday night if you need some time. Thursday, my elk time isn't completing the square this time. It is a chapter 5 retest for geometry, just a session for them to ask questions, but if you need a place to go, you can sit in back and just do some work. If you got some questions in that would be totally fine because Friday's our test. Okay? All right. Thank you for your time today. Have a